I am going to explain to you how to test and repair the Samsung Inverter Refrigerator PCB board. What are the essential points to test that the fault will be repaired? If microcontroller burns, then the chances of repairing the PCB are 0%. But when its SMPS or voltage regulator or any other thing gets faulty, then the refrigerator PCB can be repaired. But it is rare that the microcontroller gets faulty. Mainly the high side of the PCB gets faulted, so I will explain to you how the high side works. This connector has a line and a neutral wire. As the voltages will pass, a safety device is attached after the connector, which is a varistor. Then the filtration circuit is installed further. A capacitor, resistor, and line filter is installed to control any electric spikes. A jumper is installed with the line filter. See, these are the two jumpers. One is for the neutral, and the other is for the line wire. The neutral directly goes to the rectification. A rectifier is installed here. It is a 2 ampere rectifier. As this system has not had that heavy load, a 2 ampere rectifier is used in it. The line wire trace goes through the line filter, then a jumper wire is installed here with the line trace as well, which is attached to these jumpers. Then this one pin is for the module pin, the other pin has a fuse attached to it. The fuse is of 2 amperes. If the fuse burns in the PCB, it will turn black. Otherwise, checking the fuse is important if not burned, whether continuity is present in the fuse or not. This is the line wire trace which is then going towards the rectification circuit. A rectifier converts the AC voltages to the DC voltages. When the rectifier converts the AC to DC voltages, we should get 220 DC voltages on this side, but boosting capacitors are installed here. The capacitor value is 10 microfarad. When we attach the capacitor in series, then the voltages increase. In parallel, the capacitance of the capacitor increases. Now here in this circuit, the capacitance has been increased. Both are 10 microfarads, meaning they will be counted as 20 microfarads here. The voltages on both the capacitors should be 310 volts DC. The rectifier DC positive trace wire directly goes into the DC chopper. See, this is a DC to DC converter. This circuit will not be complete and not gets on until and unless its switching mode works. Let me explain this as well. This is the negative point, which has a zero value resistor installed with it. If any electricity fluctuation or surge happens, this zero valued resistor can get damaged. It works as a fuse. When this resistor burns, the source pins here will get no supply. The whole system will not work. Then check the voltages till here, if the voltages are available before the resistor on these points, and voltages are not passing after the resistor, then this resistor is faulty. If the resistor is okay and the PCB still does not turn on, this switching IC could be faulty. Let me tell you the switching IC number. TOP253PN is the IC number in it. Change the IC with the same number and hope the PCB will work. What are the signs when IC gets faulty? Check the source pins of the IC, which are attached together. If you are getting 320 volts with the source in this resistor, it is possible that the IC is faulty. Then check the voltages on the drain. Attach one probe here and the other probe of the multimeter with the drain of the IC. If we are not getting 320 DC volts here, it is confirmed then this IC is faulty. The other possibility is that if it does not get the feedback. This optocoupler generates feedback for the system. The optocoupler number is 817. And how it generates feedback. 13 volts should be present on the upper point of the resistor, the resistance of the resistor is 100 ohms. On the emitter of the optocoupler, 13 volts should be present, and on the collector, 5 volts. This 5 volt will be the feedback. See this capacitor C105. We should get 5 volts here as well. And if the 5 volts are available here, then it means the circuit is working and doing the switching as well. After checking the PCB, all the voltages are okay, then the low side of the PCB board could get faulty. The first possibility is that this grounding capacitor is installed here. Let me show you the front side of the PCB. This is the grounding capacitor. If this grounding capacitor gets shorted, then it could create a fault. The capacitor number is C106. On capacitor number 112, we should get 12 volts. This is the voltage regulator. The left side is the input, and the right is the regulator's output. This big bump is the ground of the regulator. We should get 12 volts on the input and the ground. On the output, we should get 5 volts. If the emitting diode of the optocoupler also gets faulty, then the PCB will not work as well. This means that the optocoupler shows 13 volts only but not the 5 volts. This indicates the emitting diode is not passing 5 volts to the further circuit. Friends, let me tell you this, on the high voltage side of the circuit, the voltages are monitored. These voltages are monitored through this switching IC. I am showing you its circuit as well. If the monitoring voltages are high or low, the switching IC will not turn on and the PCB will not work. These 4 resistors are installed in series, which are the preset resistors, through which on the lower point of the resistors high voltages and on the upper point of resistors low voltages are monitored. The switching IC checks the preset voltages. Keep a check whether the voltages are high or low, and whether the preset is working fine or not. If the preset gets faulty, then the PCB will also not work. Now let's talk about the IPM PCB board. I will explain this IPM PCB to you as well. The line wire connects here and the neutral wire on this side of the PCB. The line wire is connected to the fuse. Then the line and neutral enter these points. Then with it, the rectification circuit is installed. The rectifier is 5 amperes. If the rectifier gets bad, then the system will also not work. The fuse will burn again and again, the circuit breaker will trip installed in the electric panel installed in your office or home, indicating that the rectifier is faulty. Then a boosting capacitor is installed. 220 volts DC enters from the DC pins of the rectifier, which by the boosting capacitor get boosted. The voltage on the boosting capacitor should be 320 DC volts after being boosted. After this, a switching IC is installed, and then an inductor. This is not SMPS or switching mode power, rather, a buck converter circuit is installed. The buck converter steps down DC to DC voltages to get low voltages. We can also get low voltages by rectifying AC low voltages. It is possible to get low voltages in both cases. IC number installed is LNK305PN. It is for switching the buck converter. The SMPS IC I told before. There the electricity passes from source to drain, as the negative always flows towards the positive. But here, a positive supply is given. Therefore a 100 ohms resistor is installed here. This is also a sort of fusible resistor, as when high voltages flow in this circuit, the resistor may burn out. We should get 320 volts on the drain of the IC. We should get 15 volts on the source, which further goes to the capacitor and the inductor. We should get 15 volts at this point because it passes through an inductor, so we should get 15 volts here. The ground wire of this circuit is common with the capacitor. These 15 volts flow towards the IPM pins. And if the PCB is not working, then these 15 volts are also flowing toward the voltage regulator as well. This is the voltage regulator. The regulator number is 7805. We should get 5 volts from the output of this regulator as 15 volts flowing and it is the input. The pin in the center of the regulator is ground, and the left one is output. If 5 volts are not passing on the output of the regulator, then it means this regulator could be bad. If 15 volts are not passing in the circuit, then the problem is in the buck converter. Possibly the switching IC could get bad, or these 2 capacitors. A rare possibility could be of this diode as well. But mainly the capacitors and the switching it get bad. Both the PCBs communicate are not electrically joined together. Rather, they communicate with one another. So let me explain this as well. See this connector, and the voltages are also written on the connector. You can easily read them and check the voltages on the connector. The communication wire is attached to this connector on the other PCB. Check the voltages here as well to see whether they are the same or not and if these optocouplers will have any problems. Then the PCB will not communicate with one another. The compressor will also not start. This is in today's video. I will catch you in the next one. Click on the left or right thumbnail on the screen to watch our next videos, and subscribe. It's absolutely free. Thank you.